Earthrise Education team to the iHeart Talk Tuesday today. We are going to hear from four people today. Ed Boyda and Kim Young will start off. Ed Boyda and Kim work with a California environmental nonprofit called Earthrise Media. They'll tell us about the education initiative they've developed at the Earthrise and their partnership with iHarp, where students are gathering data on meltwater lakes and cracks on the Greenland ice sheet for use in future machine learning models. This work is also in collaboration with Mike, who's on the iHarp team. Ed was an associate professor of physics at the St. Mary's College of California. In 2018, Ed joined the Earthrise media company and became a satellite enviro investigative journalist. He reports on illicit mining and logging around the world and codes machine learning models for data platforms like Amazon Mining Watch. Kim teaches 9th grade world history at a school near Boston, where she weaves experimental pedagogy and environmental justice themes into the social science curriculum. She's also a National Geographic Fellow. Later, Kim will introduce Ali Pressel and Stephanie Dolan, two of the teachers participating in the project who have come to share their experiences from the classroom. Thanks. Over to you, Ed and Kim.
Thank you, Anish. Really pleased to be here, and yeah, just pleased to be working on this project and to get to share some of our preliminary results. I'm going to just take 2 seconds to share my screen. Now, hopefully you can see some slides. Stephanie has to drop early, so I'm going to try to give some brief background on this initiative and then hand it over to Kim to enter into conversation with Ali and Stephanie, who are the two of the teachers participating in this, and to share their experiences working on this project in the classroom. So I should say, like, at base, what we're doing is, you can think of it as an experiment in pedagogy, and it's an attempt to bring in environmental science, some aspects of environmental justice into the classroom using recently developed tools and techniques, and as an engaging a way as we can imagine doing. And the core of the work that we're going to be describing is satellite-based data gathering challenge or exploration set up for students in classrooms. So Earthrise Media itself, of which Earthrise Education is a part, it got started as an effort to get satellite imagery into the hands of Earth journalists. And at the time, I remember just thinking about climate communication and wishing that more people could see, as I could see, the sort of just with their own eyes, the change on the Earth's surface. And I have to say, like, if you can think back to 2018, when I think back to 2018, like, there's a lot more climate literacy now than there was back then. Like, things are improving, even if there's a long way to go. So we could see early on that there was some potential for inviting students to do some of the same things that we were doing, which in a lot of cases just involved like bringing curiosity and close reading skills to satellite imagery. And there was another sort of, like, I don't know, early clue that we had, or early idea, or something that we noticed which was that the potential to connect students with researchers or journalists who actually had a need for data derived from satellite imagery could be a real motivating factor. And gosh, if the students know that there's somebody out there who needs the output of their work, they're not going to let them down. Like, I mean, we've seen that over and over again. And so the process, I'll give you some examples in a minute, but the process that we've kind of worked up and laid out looks something like as follows in my sort of wonky flow chart here. But it's an effort to connect some researcher with a distinct need for data that can be fulfilled with satellite imagery, and we try to build a curriculum which could be from a few days to a week around that specific environmental theme and data need, and then put that together with some imagery and a tool for labeling imagery. It could have been Google Earth or QGIS, but we built a custom tool that is simplified and hopefully user-friendly for the classroom, and that has some sort of built-in aspects for giving peer feedback and fostering collaboration in those ways. And then get this into the hands of students. And the hope is that the student learning is motivated by the promise that at the end there is this task, this exploration or investigation that they can apply themselves to, applying what they've learned, and then along the way they're invited to think about collectively about some aspects of how the data is gathered, and there's some very natural points for collaboration. And at the end of the day, if you're sort of looking at a computer screen, wondering whether what you're looking at is a village or a mine site, and you have to look at this or that detail, you can bring in a peer and have a conversation around that. And so to invite the students into this process, and then at the end they produce data which might end up in some published journalism or in a report or part of a machine learning pipeline. So just to give you an idea of what this is about concretely with some previous projects, some things that we've taken on in the past include mapping the slopes of Mount Everest for a Nat Geo Explorer, finding and identifying illegal open pit gold mining in Yanomami indigenous territory in northern Brazil, marking clear cuts in another indigenous territory, this time in the Philippines, where there was this data was needed to sort of petition the Philippines government for enforcement and to stand by the promises of protecting this territory. And then asking the students to validate machine learned detections of open waste sites. There's an example here at upper right of one such site spilling into a river in Indonesia. To do some close reading of these sites and understand, give feedback to this machine learning pipeline and platform. So, we're educators and like practitioners in this work, and trying to make it work in classrooms, and it would be interesting to study its efficacy, but anecdotally we keep getting feedback from classrooms, which is really inspiring and keeps us going. And I think here's just one example from a teacher in Iowa who worked on the Yanomami territory mining investigation and with her students, and at the end the students decided to sort of reset their Model UN class around indigenous land right issues, and like for me, like as a former educator, teacher, like that just feels like, wow, like we connected with the students, like they did this and it meant something to them, and that just like feels really good. That's so so what we're talking about today, and this current project in collaboration with iHarp that is going to be the basis for most of the talk, looks as follows. And so this is now a view of the tool as a student would see it, with some SkySat imagery of the Greenland ice sheet loaded and some sort of markings in progress. We are we're working with Mike McFerrin. I assume most of you know him, that he's a climate scientist, a glaciologist at University of Colorado Boulder. And he is interested in the summer meltwater lakes on the Greenland ice sheet and understanding their distribution as they're being found higher and more further inland on the sheet than expected. He's also interested in the cracks that are nearby or under these lakes, and I'm going to apologize to Mike in advance for giving such a simplistic sort of version of the science. But what I understand is that sometimes these cracks can open up and drain these lakes very quickly, like in the matter of hours, and that water can percolate down and end up on the bed of the ice sheet and lubricate the ice rock interface, and therefore play potentially, I think this is a sort of an open research question still, but potentially play an important role in ice sheet dynamics. And so the students' tasks here, and part of this challenge, is to map out meltwater lakes, nearby cracks, and we also threw in moulins as sort of a fun challenge for the students. The students found moulins everywhere, and so we're not using that data, but they were very enthusiastic and looking for moulins. But and then we're underway. There's another round of data collection that's where we're looking at for lakes as they evolve through time, through the summer months in 2019. So more data collection in progress with a slightly different focus. And then the goal is that this data, these polygons, which you see drawn here, will get used downstream as labeled data for machine learned detection of these features. And with that, I'm going to hand it over to Kim.
Thanks so much, Ed. If you can stop sharing, I think we'll just go to kind of screens and conversation for the next moment. So in a little bit, I'm going to talk about some of what I would identify as some of the keys to success in rolling this out as a classroom outreach program. But what is actually more exciting is we do have one of the teachers who participated here with us today. So Stephanie, thank you so much for putting your video back on, and you can unmute. So we're going to kind of turn this over to a little bit of a conversation between Stephanie and I about like what this looks like on the ground and in the classroom. So Stephanie, first of all, can you kind of introduce yourself a little bit more, where you're coming from, how long have you been teaching, what classes do you teach, and what do you love about teaching? I always love giving teaching a little bit of a shout out.
Sure. So my name is Stephanie Dolan. I am a science teacher at an independent school in Portland, Maine. I teach 8th grade science and high school chemistry. I think really what drew me to teaching was sort of building relationships with kids. And then I had started off, I had a science degree and thought I would go down a field. And then I kind of needed a little bit of a job before I went on to the next phase of university. And I picked up a teaching job and realized like, oh, actually, I think I really like this. So again, I've been teaching 20 years. And this project was overwhelmingly a success for me and my students. And maybe Kim, I don't know if I want to turn it back to you and I can kind of get into the. Yeah,
I want to kind of pull out a little bit first. One thing that I think is difficult for us as teachers is sometimes we are very locked into what we have to teach. It kind of depends on our school or our context about how the flexibility. But even if you have maximum flexibility, it still takes time to do any of these things. And there's a lot of opportunities out there. Is there anything in particular that initially drew you to this opportunity as we were kind of sharing about it? Like what kind of drew you to click on it or like say yes and follow through? Because it could have broken down at any point,
Right. I think so. For me, one of the big key parts of our actual science department has our own mission statement. And one of the things right in our mission statement is to engage in real world research. And I think for a high school course, that's a little bit more tangible. But for middle school, I'm like, I don't really know what that looks like. Here in Maine, again, we live right on the coast. Look out the window and we're in the Casco Bay. our bay, like our region, has some of the fastest warming water in the US. And our kids sort of have felt, and our school has sort of felt the effects of climate change in our lifetime. So in addition to teaching, I coached the Nordic ski team. 10 years ago, we would have snow, November, February, like November, December, and now it's lucky if we have snow by January. So I think for me and our students sort of understand the idea of climate change. So, but to actually engage in real world research, that's always like a bit of a jump for me. I'm like, I'm not sure how do I actually do that without it being kind of playing around with fake data or making something up. I got connected with Kim through actually like a Facebook group that I'm part of. So it's like a polar research group, and Kim put something out on there and I clicked on it and filled out the form and then never really heard back for a bit. And I'm like, well, we'll see where it goes. And then all of a sudden it seemed like everything pushed into high gear. And I thought, well, I'll give it one evening and sort of see what it is. It was sort of like an hour. And I'm like, all right, they claim it's easy. And then clearly, as soon as I looked into it, I said, this has been designed by a teacher, somebody who understands like the constraint of like, I can't click on 85 different links to find the thing that works. Everything was in one spot. I said to myself, I'm like, I'll give it an hour for myself. And if I can make it work, then I'll think about rolling it out. And within 10, 15 minutes, I was hooked. I think just the thoughtfulness with how it was put together. I really looked at it and realized like, wow, I could turn this into like, I always say those sort of days for me, right, that come up on a holiday. So right before Christmas break, those are kind of wasted teaching days. And I'm like, well, I'll give it those few days. And as soon as we introduced it with the students, the kids were automatic, like right away hooked. The fact that they were connecting with actual scientists doing real data at age 14 and 15, it's sort of what I would have hoped would have happened. And I thought at the end of the day, you know what, if it's a few class periods and that's it, that's fine. But the kids got really hooked and they felt like, oh my God, I'm actually doing something legitimate. And they could, middle school, high school can kind of feel when things are fake. And it felt like it was real and authentic. And I think that's what really pulled me in. But more importantly was actually the reflection afterwards, I think. The kids were
Before you jump to that, I would wondering if you can kind of illustrate a little bit more for us about what it kind of looked like in the classroom. Did you find, did kids want to work independently? Did they work in groups or pairs? What were kind of the things you overheard like in the moment? And then I know you have some fabulous debrief stuff that you did with them.
Yeah, so it really varied and I kind of left it up to the kids. So I had some kids that were so individually driven. They were like, I want to be like, I want to tune out and like really focus on the work. And then other kids who wanted to really work together. So I kind of left it a little bit up to the kids. I thought in the end, as long as the kids are working and they really understand the task, I was okay kind of giving the kids sort of that flexibility. So it really kind of varied by group. But I really can't stress enough the ease that one document you put together and I'm like, I bookmarked it and I'm like, okay, where do I go today? And like, it was just very easy to find how to make it go, 2 days. Mine ended up rolling into 2.5 weeks. And again, I think because there was enough breadth to it, but and I think like often as science teachers, I always consider myself like a jack of all trades and a master of none. And you really made it accessible for the teacher. I didn't have to become like, that's not really my background, earth science and all of that, but I could feel the passion from all of like Mike, him kind of giving the talks, the fact that you had everything video recorded. So if it didn't work out in real time, I could just show videos. It was how incredibly accessible the program was for me, that really made it such a success.
Well, thank you so much, Stephanie. It was definitely my aim, but I think an interesting thing you pointed out about kind of I actually come at this from a medieval world history perspective. So the content is also not my wheelhouse, but I think in some ways that's a strength because then that makes it so we can roll it out to more classrooms. Because it's like if I can at least understand it enough, definitely can work in STEM classrooms, can definitely work in polar science classrooms. So that was definitely a goal. So I'm glad that one worked. Especially, you know, we always have our dreams, but then with teaching, there's always the reality as well. Can you tell me a little bit more? You did a really great piece that we actually didn't build into the guide, but you know, as a strong educator, in some ways, that's where the actual learning happens and some of the debrief and processing that students reflect back afterwards. Can you share a little bit with kind of how you did that? Because we didn't kind of support you in that. And also what, I know you have some either specific things you could read from students or just in general, some of the student feedback. You did a great job of capturing that.
Yeah, so part of it was I had back in September written a grant through the Battelle Foundation to take a group of kids on because here in Maine, I've become really kind of interested in that polar science portion. It was sort of a portion of science I really didn't understand much before. So I wrote a grant and was awarded a grant to take a group of students into the backcountry and in New Hampshire to learn about polar science, in particular snow science. And so this looked like, wow, once this sort of came on my radar, I'm like, this is a great way to sort of introduce that topic and then see how kids take it. You know, I could only afford to take 15 kids on that trip. And so this was sort of like a way to introduce the topic to everybody and then sort of see where the interest fell with kids. So really, it became sort of like one of the ways that I actually had the kids apply for that program. And the program ended up, you know, the kids, it was sort of like a free program and opportunity for them. But in true 8th grade fashion, I have everything just written down in their little science notebooks. But one of the things, so I think what makes this one feedback, it's a little hard probably for you to understand, but this is a student who is essentially would be at best a D student, not very engaged, like a nice kid, but just really has a hard time finding like that hook. And this was the project, and I was floored, but it was the project that hooked this kid. And she wrote at the end that this project was absolutely eye-opening and very misspelled. I never thought in an 8th grade science class I could do something that would impact such a big project. I found it absolutely interesting. Learning about and then all the lakes and all the features. But for this, let's see here, the end. So excited to come to science class, and I love that we can get to learn even more about climate change and to feel like we're making a real difference in something that's so dark. And I think that was the big thing, is that the news, our students are constantly bombarded with just bad news after bad news after bad news. And to actually give the kids an opportunity to do something where they feel like we're learning about this really big, heavy topic, but we can do something to help it. And I think that's, as a teacher, always been something where I'm like, how do you balance that, but still give them the opportunity to make an actual change? And that student ended up going on that trip with us, and, literally has kind of changed the trajectory of her life. Grades have come up. She's just super hooked in. So I think for me, and that's just one case, but overall, the kids were just shocked that they could be involved in a project that they knew was not fake, collecting fake information. And I think that was sort of the big surprise for me.
Yeah, I definitely think that was something, especially for me as well, coming out during the pandemic, when we had kind of education stripped down to its just bare bone essential parts. My students kept coming back to the thing that matters most to us. If we're going to spend our time, we want to do something. We want to have an impact. We want to see a connection between, if we're going to take our time to learn something, we want to know where it's going. And I've definitely kept that with me as we moved on post-pandemic of like, well, how can we circle back? Kids always want to be helpers. They want to feel like, and they want to feel validated and seen, like that they can be an equal co-contributor, even as a middle schooler.
Yeah.
Yeah, and I think when that student feels seen and like it's going somewhere, all of a sudden it can really flip, their insights. So thank you so much, Stephanie, for sharing and dropping in here today. I know you're going to have to move on to your next thing, but thank you so much.
Yeah, well, and the only other thing I'd like to throw out is the videos. Like Mike sent a thank you video, and that was huge. The kids realized, like, oh my God, there's like this guy in Colorado, and like he's got letters after his name and before his name, and like he's thanking us. And so I think that was really impactful to just sort of have that loop closed. And so again, I can't overstress, and I think, Kim, this probably goes to you, is the ease at which that document, everything was put there. Teachers could add to it. I used a lot of other teachers' resources because I felt like, geez, I'm coming at this pretty green. I don't really know. The video links, everything just made it easy. And as a veteran teacher, it's hard to find projects that are easy and have an impact. And this was overwhelmingly one of the easiest ones and most impactful that I've worked with. So thank you.
Well, thank you so much. And thank you to your students. The data was amazing. I mean, that is the great piece about this, is that we need the data. Ed's going to talk a little bit more later on about how he was able to process it, but this is data that was needed. The students contributed it, and that full circle, of having Mike then say, like, I got your data. It was awesome. Like, as they're sitting in that corner, circling lakes over and over again, they're like, is this going anywhere? And it's like, there's a human also behind the science and behind the data. But thank you for joining us and sharing so much. I'm going to do something a little off script, so we'll see how this goes. But Charu, you're here in the audience, and I don't want to put you totally on the spot, but we have a teacher who is going to be joining us in the next round of the challenge. So you can message me, Charu, or if you turn on your camera, I don't know where you're at, but at any point in time, if you want to chime in and talk a little bit and share about you're going to be joining us for this next round, and you haven't had a chance to participate yet. But if you could tell us a little bit, if you feel comfortable, about what kind of drew you to join, if you can kind of introduce yourself. I know you're joining us from India, so no, don't feel pressure to respond. But Charu, if you want to kind of join in, feel free. Like,
I'm so sorry. This is a very it's 2:00 here.
Yes,
and,
so I'm going to put you on the spot in the middle of the night, but I also wanted to recognize that you are here.
You're seeing me at my worst, but yes, that's the comfort we have to work with this kind of a group. Yes, and I'm really looking forward to it. And like Stephanie mentioned, that it's a very detailed document, and I myself, with not a science background, but still I could lay my hands on it, and only the sheer passion to work for the climate change has actually dived into me into taking up this project. And hence my students at this VR also, they have joined in here to actually listen to it, and they were encouraged to know how they can contribute towards the project. And yes, we are looking for some more helping hand from your side for the tool, and I hope we are able to contribute in a meaningful manner, and more such sessions after we actually go through the project. And thank you team iHarp, and thank you team Earthrise for giving us this opportunity, and we really look forward to it.
Well, thank you so much, especially in the middle of the night. But I just wanted you were on. So Charu is going to be joining us in the next iteration of the challenge, and her students are going to be helping us identify some change over time with the lakes. And we're really excited to have you. Thank you so much for joining us. Okay.
Thank you.
Allie. Okay. Yep. I think something else. So I am going to share my screen and go in to a little bit more about some of the nuts and bolts about what I think helps make this successful. So this is an image from my own classroom. I asked Stephanie a little bit about kind of what it sounds or looks like in the classroom when doing one of these satellite imagery investigations. So here's a little bit of video.
Maybe that could be it. Oh no, see, every time I zoom in.
Yes, and
wait, maybe not. Maybe they're just trees.
Maybe they're trees. Maybe there's you never know. So when kind of working with students in the classroom and using this tool, it is really interesting, as Stephanie said. Some students want to work together and they consider it to be a very social activity. They will kind of flip their computers around and ask, like, do you see this? Do you see this? What do you think it might be? Other students go in the corner, put on their headphones, and it becomes actually kind of meditative and relaxing, and they're in the zone and they're focusing and they can polygon all day long. But I want to highlight, so in general, when I come at this as an educator, some of the tools that I try to add to the challenge or the collaboration and investigation to make it work. Stephanie highlighted a lot of these things, but I'm just going to kind of reiterate them at a more general level. So as Stephanie really emphasized, authenticity is something we're striving for and what makes the collaboration so successful. In all working with iHarp and working different organizations, we make sure the call for data is authentic. Someone needs this data and the students can help. There's so much students are capable of doing. Here's kind of images where some of students helped with gather data for a Reuters article, but also knowing the scientist behind the call to action. Mike was great in adding call to action videos and thank you videos, and that personalizes it for the students. They want to know not just content wise what they're involved with, but who they're helping. So centering the scientist or the science team or the people who will be impacted really drives students. They want the face behind the investigation, and doing that through videos or talking about who's going to be using the data is really helpful. Also having some of the Zoom opportunities, not only to Zoom with me but to Zoom with Mike. We did, for this iHarp challenge, have an evening session that we recorded where Mike gave a content overview for the teachers. And then he stayed after and did stayed after an extra half an hour and did Q&A, so the teachers could ask some clarifying questions and be better prepared for what their students were going to ask. In terms of recruitment, so how do you get teachers to sign up for these outreach activities? How did I kind of draw upon different tools? How do you get teachers to sign up? Definitely a multi-pronged recruitment effort. So on the one hand, I have different social media accounts, and I just kind of did a general all call, pushing things out through Facebook, Instagram, and Twitter, saying things under the hashtags or realms of citizen science, polar science, Greenland, taking action, civic education, in those different veins. And that will occasionally lead to maybe one or two teachers, but it's something that I definitely kind of put it out as an all call if I think we have the capacity to support it. But what I found has been most beneficial is either targeted recruitment. Teachers always know somebody else, so I will reach out to teachers I've worked with in the past, or teachers at different areas of the country, and kind of forward them the opportunity and say, who do you know who would be a really good fit for that? And they'll get back to me. There's also, in the realm of polar science, which I think a large number of the scientists and individuals in the room today are interested, particularly in polar science. There are two really dedicated professional development groups of polar science educators or teachers who are interested in polar science. And these Facebook groups are phenomenal for drawing teachers to participate in outreach and curriculum activities. So I found a National Geographic group. There's two different National Geographic groups, one through the Grosvenor Teacher Fellows. Teachers who participate in that program, some of them travel to the Arctic, so they're always really interested in coming back when they're back from their expedition and finding ways to connect their students directly with the Arctic. There's also Polar Educators International, and then the Polar Trek community, that are really strong networks of polar educators who are looking to continue to integrate polar science into their classroom. So these are really great places that I went to recruit the teachers. Also support. So it has to happen in so many different ways. Stephanie mentioned that kind of a live quick start Google Doc. A cool part about this was that the document was dynamic. I developed a series of resources and kind of curriculum materials, some learning objectives, connections to the SDGs, the Sustainable Development Goals, some key questions, and then I also put in some tool supports. But I made sure the document was live and accessible to the public. So as each teacher progressed through the challenge and progressed through the collaboration, as they added different resources. So you'll see highlighted there an ArcGIS story map that Ali Pressel made. That was a particular skill set that she had. She took the document and she translated it into this wonderful student-facing resource. I didn't have those skills, but because this document was live, she could send me the link to it. I added it, and then all of the teachers who were a part of the challenge got access to that. Ian Devlin also, he looked at Mike's video and he said, oh, I'm going to make it into an ed puzzle. So an ed puzzle pauses and asks students comprehension questions as they're watching. So Ian made that, he shared it with the group. I was able to add it to the Google Doc. So as teachers were going through the challenge, we could collaborate and share resources. I think a really key part of supporting any educational outreach efforts is that the curriculum materials have to be multimodal. So there needs to be videos and slideshows and graphics to help students and teachers progress through whatever you're doing, and that everything has to be offered. There needs to be synchronous opportunities and asynchronous opportunities. So anything that we did, we recorded. So if a teacher couldn't make it, they could view it at a later time. But I also made myself available kind of during different hangouts or to present to different classes if they needed that live support. So having a balance of do it on your own time or do it with me there to present. We also, the live document allowed me to be responsive to teacher needs. They said, you know, Kim, we loved that 20-minute video you did on how to use the tool, but can you make a student-facing one that's under 5? So yes, I can. That's great feedback. That's something I just kind of overlooked. I was able to respond to the student or the teacher's request immediately, add it to the document, and kind of create a better resource than what we had before. Also, in creating the challenges, we look to create a balance between multiple paths and clarity. We don't want to give students and teachers so many options and so many buttons to push or so many pieces of data that we need that it becomes overwhelming. So for this first round of the challenge, we were looking at lakes, crevasses, and as Ed mentioned, the famous moulins that seem to appear all over the ice sheet, despite us saying it'll be a really rare thing that you'll find. So we gave teachers kind of 3 things to look for, and then also some suggestions. Well, if a student is struggling, just have them trace lakes. And this upcoming iteration of the collaboration, we're looking for lakes, dry bed lakes, and refrozen lakes. And as I've started to work with some teachers, I said, you know, if students are struggling, track the progress of a single lake over time and just identify if it's full or if it's drained. If you can't quite identify refrozen, kind of ignore that. But for students who are excelling, and I get really good at this, there's an option to kind of extend and show a higher level of sophistication as well. So balancing that flexibility of different options of how to collect data. Recognition, really important for success. So one thing we've started to do is making sure we are sharing the data back with students. When we're able to show them, here is what your collective work looks like. Here is what you were able to do, again, to reinforce. I think that celebration and recognition reinforces the authenticity. We needed your help, and here's what it looks like. Having that video from the scientists saying, thank you for your work, I'm going to use it, means a lot to the students. Also, having that certificate of participation in that's a great thing for students to take with them. It's a way to grow their resume. It's a way for them to show colleges and future institutions ways in which they've been involved and active in the scientific community. That also helps appeal the challenge to an even larger group of educators in a larger set of classrooms. It's intended to be interdisciplinary, not necessarily be for any one person. So having all these various paths and ideas are really helpful. So now I'm going to hand it back over to Ed and talk about, okay, well, we gave you, I mean, how many polygons initially? How did you make this usable and doable?
Yeah, so thank you, Kim. So there were 650 students that participated in this project in January, and they submitted 24,000 findings of different features on the ice sheet. And, you know, so their learning process through this is very important, but part of the promise at the end that we need to follow through in is making sense of this data and making it usable and valuable. And so that's part of my job. In the past, I've hand validated student findings, and this time with 24,000 staring me at the face, I finally buckled down and made a mostly automated algorithm to do it. And so I'm excited to show a little bit about how that works. What you're looking at right now on this slide is just for your amusement, the students like to send me missives through cyberspace occasionally. In this case, they sent me Ohio and Lake Pontchartrain in addition to some actually good data. But could you go to the next one, Kim, please? So this is now we're back on the ice sheet here, and I've zoomed way out to give you some like spatial context. Ilulissat's in the upper left. And then we're looking at some long strips of SkySat imagery over the ice sheet there. And the findings in pink, these are all those that the students labeled cracks. And one thing that you'll notice immediately is that some of them are much too coarse. And, you know, like a student has just decided like, there's cracks in this area, and they put a blob down that covers, you know, hundreds of square miles, and that's not what we're after. That's not useful for us. And everything in that you're seeing in this view, except for the specks, is basically stuff that we want to discard from a data perspective. But even those that are drawn in detail, there's a lot of variation in shape, size, position. You know, these are hundreds of students like looking at features and making different determinations about what they are or aren't, and where exactly, you know, how long the crack extends and where to stop drawing a lake, et cetera. There's a lot of subjective, you know, decision making that's happening here. And there's also a lot of overlap in these features, and I wanted to use that redundancy as a resource in distilling this data into something useful, and basically try to do a voting type procedure or a wisdom of crowds approach, where the rough idea being that if a lot of students say in this spot there's a crack, then probably there's a crack. You know, that's bargain basement, and then try to make, you know, take that idea and make an algorithmic procedure out of it. Could you go next, Kim, please? So here at left in text, you have sort of an outline of this algorithm, and at right, you have kind of a flow chart through different stages of the process. The one labeled SkySat image is just a view of a particular meltwater lake with a number of cracks, visible cracks running vertically under the water there that we want to, this is, you know, the sort of the target that we want to capture with this data gathering process. The next one in pink, this is the raw student data. And remember I said that like sometimes, you know, students will just submit giant blobs saying cracks in this region. And so what it looks like when you zoom in is just like everything is a crack. So the first thing that I do is just kind of an ad hoc procedure of getting rid of the stuff that's too coarse, either by size or by number of vertices of a polygon. The heuristic there is basically that the students who put more vertices are doing more careful work, and so we want to, you know, prioritize those findings. And after that, after that rough clean, we end up with the findings that are in purple there, lower left. And you can see that there's still just like an incredible number of findings. Now we're zooming in, we're honing in on these cracks, but there's still like just, you know, overlaid everywhere. And if you just took like a union of the findings, you would just get, you know, the lake as a whole. So then the guts of this procedure is as follows. You take, I create a point grid, and at each point, find the number of these polygons in purple that intersect that point, and then also the number of polygons relative to the total in this component of the union of all crack findings on the ice sheet. And so basically, like if at that point it's been labeled cracks a lot of times relative to the number of polygons that are in that local neighborhood, then we say, okay, it's a crack. It's probably a crack. And then you capture all those points, and then you get what you see in the lower right, which, and this is a little bit magical to me, that you know, because you certainly can't eyeball it looking at this data in purple, all these polygons, to see that there's actually, yes, the students collectively prioritized in the overlaps of these polygons the right set of points. And you can see it's quite detailed, actually. Like, so for instance, towards the right, there's a couple of cracks which are almost parallel but diverge a little bit towards the top, and you can see that if you look at the, you know, map back to the cracks in the SkySat image at upper left. And similarly, the furthest right crack that got labeled has a little jog in it halfway, and it's a little hard to see probably on the video, but you can see that as well if you look carefully in the SkySat imagery. So it's like quite detailed how it resolved through this process. Can you go next, Kim, please? Okay, and so then I take those points and reassemble them into georeferenced polygons. And here you're looking at some of these results, both lakes in blue now and cracks in yellow. You see this lake that we've been focusing on, the cracks nicely outlined. In the upper right, you see just sort of, I put that, these are all from the same sort of local area on the ice sheet, but this example, upper right, just shows some of the level of detail that these students were working. It's even hard to see in this image at the zoom level that I took this screen capture, but like both of those crack complexes actually have intersecting cracks at different angles that are expressed correctly through the polygons there that this came out of the resolved student data. And so let's see. I mean, I guess just to sum up, let's see. There was 24,000 polygons, and that distilled down to 316 lakes and 331 crack complexes. It's relatively small, and we were like, because of the imagery we had, we were working on a relatively small section of the ice sheet, and we're hoping in this sort of next round of work to expand the geographic and temporal coverage through Southwest Greenland and also in the Northeast, and get more coverage. But you know, like, I'm a machine learning practitioner, and when I look at these kind of outlines, I feel like, you know, this is credible data that could be plugged into a machine learning model and a machine could learn to identify you know, lakes and cracks from this, given a sufficient quantity going forward. And yeah, so I hope that this ends up being, you know, a valuable contribution to, you know, to the ongoing, you know, research on sort of the distribution of these features on the ice sheet. Yeah, I just say, like, for the, you know, I'm pleased with how the data came out, and also just pleased with the application that the students brought to this. It's just like very obvious, and when I look at the data, and I've done this many times and seen sort of variety of responses from students, just, you know, that they really invested themselves in this work, and you know, and I think that is an expression of their, you know, I take it as an expression of their interest and engagement, and so feel really gratified by that. I guess finally, just want to close with thanks to all of those many people who've worked with us on this, the teachers, students, and the whole iHarp team for encouragement and support. And with that, I guess we have a few minutes for questions if anybody has some.
Before we start into the question answers, I just wanted to say a really heartfelt thanks to all of you for really putting in so much effort and going down to the grassroots. And I was really encouraged with all of the stories from the classroom. Did I hear it correctly that there are some students also in the audience today? Maybe Charu said that, or I could be wrong, but are there any students in the audience?
My students have joined in. They were curious to actually know what is it that they're getting into, and they were curious to understand the whole project. So they were willing to join in at this VR as well.
Absolutely. Can I speak to the students for a couple minutes, if that's okay?
Sure.
You know, you're welcome to turn on the camera or say hello, or at least raise a hand so we know who you are. But just to give you a context that there are several scientists and PhD students in here. I'm sure you'll hear from them in a minute. A lot of them will be using your data. So what you just heard about the images and the machine learning attached to it, what we hope to do is through these, 600 or so labeled images, we want to feed it into machine learning AI algorithms to do auto annotation or annotation of these features, and eventually expand it to understand what processes are happening on the ice sheets. And some of our polar colleagues can also speak to it, but your data will actually help us create those algorithms. Otherwise, it wouldn't have been possible, because any AI algorithm, as you know, relies on very well labeled data. So I think looking at this data, everybody would agree that there's a lot of good labeling involved, a lot of good validation involved. So I'm really looking forward to using it. One other activity that we are looking at, I don't know if Dr. Mokbal is here, but we are hoping to run this data in a competition that who can use this label data to identify geospatial features in using machine learning algorithms. So there's a conference called ACM6 Spatial. We are considering hosting a competition there to use the label data and create more efficient geospatial algorithms. That's still in the works, but there's lots of good stuff coming from it. And I think there'll be other partnerships extending from this as well. I hope that helps answers, some of the questions that students might have. But I think iHarp scientists would also be happy to answer questions if the students have anything. You can feel free to unmute or put it in the chat. And I don't want to hold up other questions, but I just wanted to make a note that this is really very appreciated activity. Thank you. Questions, comments from others? Yeah, go ahead, Karen.
I just want to thank you, Ed and King and other teachers and Charu as well, right? And simply, what is the most simple thing, easiest, make it easier to impactful. You just done such a great job and make it so smooth. And so I hope that one day teachers in Baltimore regions and can also be participating. Ada, can you talk a little bit about what's the next step would be? I know that I had some conversation. You told me that the show will be taking off. So can you just talk about your thoughts on the next step?
Karen, do you mean like next step for this project or next step for?
Yeah. So do you have any plan for future involvement with teachers?
So right now, I mean, we are sort of in the middle of a second round of this project, as Kim has described, looking at the evolution of lakes through the summer months in 2019, and once we wrap this up, we don't have a next project planned. We have for technical reasons, we're going to go through a period of retrenchment because the back end support, the company that supports the back end of this tool is kind of pulling the plug on it. So we're gonna it's retrenchment. But I think one of the things that we've come to and that we're looking at going forward is really sort of focusing on this kind of a large project and trying to scale it up to involve more classrooms, but something that we can really support with a community and good resources and in active engagement from researcher or journalist who is pulling on the data. And it's in the past, it took us a little while to come to this, so we've tried a few different things. Early on, we tried to create a lot of different investigations, but that weren't, supported in this way, that they were just kind of like standalone. If you want to do water resources in the American Southwest, here are some ideas of what you can do, but you're kind of on your own. And so, so going forward, we're really trying to do as we have done in the last couple of times, like with the plastic waste site ones, and then now with iHarp, large projects involving lots of classrooms and good, engagement and support.
Thank you. So do I understand correctly that you envision most of the effort will be on informal learning in classroom? Have you thought about real citizen science and student do it on their own or after school, or how that work out could be, or even mechanic Turk?
Do you have thoughts, Kim? Do you want to take that, or?
I mean, I think it's a possibility. I think the key part of it in terms is getting students the access code through the adult, like some sort of adult home base person for them. I think they would need, so in an informal summer camp or after school clubs, we've had some environmental science clubs take it on. A lot of my networks are more formal education, but I think this model could work well in an informal environment or a more asynchronous. We did have a lot of success during the pandemic through Zoom. We did have a lot of students doing this asynchronously over Zoom. But they do need an adult that we get the codes to as kind of a workflow issue. We need kind of one adult that can distribute the codes versus me putting them online or me generating individual codes for individual students to kind of keep all the data privacy and kind of identities of minor things like totally set. Those are kind of my initial thoughts. But yeah, I think it, in theory, works well in any educational environment.
I just to follow up, one of the thoughts that I have on this is we tried a little bit of this with the plastics investigation, and it definitely and saw relatively short engagements for the students that were on their own. And so there's something about the classroom environment, the support of the peers, the structure of the classroom, which has really helped students go deep and stick with it. And so we'd have to think about ways to sort of recreate some of that outside of the classroom, either be it through community that interacts on social media, the rich set of video kind of support tools that we had here, those sorts of considerations.
Great, thank you.
Yeah, there's definitely a social element to it of working together and being a part. I think that community could help happen online or in person, but that there's a community element we found to be important to the success.
It's great. 650 students, that's quite a lot. Some of them could be future polar scientist or AI machine learning researcher. Do you have a chance to talk about AI machine learning in the class as part of a rollout field work?
Yeah, interestingly enough, the class I taught right before I got on this call, we're getting ready to do round 2 of the investigation, and we opened up with a discussion about, is AI good or bad? And the students have a lot to say about that because their lives are really rapidly changing right now with ChatGPT, how they're doing their final exams, and they're just in the thick of this. So that is the exact conversation I used as the intro to this project. So we had kind of an informal discussion and some brainstorming, and then we asked ChatGPT. We had them each ask, is AI good or bad? And we saw then what the AI had to say about AI, which was another interesting springboard for discussion. But students are very interested in not only helping, but playing and experimenting with this tool and feeling like they're a part of steering it in the right direction. So I see that as a through line for helping keep this project interdisciplinary. A core hope is to inspire polar scientists, but I think ultimately our hope is to inspire curious minds.
Well said. Thank you, Kate.
Other questions?
A quick question. Jianwu Wang from UMBC. Great work. So I feel the work you are doing is similar to cross-sourcing, right? So many people be able to edit and to be able to label them. So there are other cross-sourcing tools like Amazon, like a Mechanical Turk. So what's any way you could connect to those resources, or any differences between I know your work focused on like high school students, but what's the difference and connections with the more general public crowdsourcing? Talk about that. Thank you.
You want to go ahead, Kim, or?
Yeah, I think from the education standpoint in developing the Earthrise tool, we were looking for something that hit the intermediate zone. We had seen some crowdsourced stuff that was more gamified. It was more just detecting like yes or no, and you could earn points and badges, and it has its value and is important. And then we saw a lot of the open source crowdsourcing GIS stuff. The barrier to entry was a little too high for a 6 through 12 educational environment. I kept trying to use them with my students and it just wasn't clicking. So when I started working with Ed, it was kind of looking for this mid-range tool. We also, in some of aspect that the tool incorporates that we didn't use in this challenge just for time's sake, is it does involve a peer review function. And that was something we wanted to have kind of a more closed peer review function just amongst students so they could practice that part of the scientific process. And this tool allows that in a little bit more of a controlled way. Ed, do you want to add?
I think one of the important differences, just like sort of in process that we've tried to, embed here is like element of exploration. Like some of the public like citizen science tools are quite prescriptive and really just like crowdsource, like you're presented with an image now, like mark it up or something like that. And there's an element of exploration that we've tried to build in, and that's one of the reasons that we include moulins in this investigation, even though it wasn't like top priority for Mike in terms of data gathering, but because it was something that was like had this kind of like hunt and find and like can't quite tell what it is, explore aspect to it, and that played in some of the it was very important in some of the past investigations, like the mining investigation. At that point, like we really had no idea where the mines were, and it was partly because the imagery was so constrained and not recent enough, and it was really like the students were out there finding these things in the like free to explore and come back with something interesting. And so that's a pretty important difference, and I think interesting for students as opposed to like these other contexts.
Got it. Thank you. Yeah.
Any other comments or questions and thoughts? I'm sure there are many PhD students who will be using this data, and they'll have follow-ups and questions. In the interest of time, I again want to thank all of you for doing this study with the students, and many thanks to our students who are here as well. As Karen said, hopefully some of them will cross paths with us, either in AI space or in the polar science space. And thanks, Anish, for hosting in the beginning as well. All right, thank you so much, everyone. Ed and Kim will be in touch, and Kim, will see you in a little bit again.
Yeah. Thanks so much, everybody. Take care.
Thanks, Anish. Bye.